We'll see. We'll see. Do you agree with your groups, though? Yeah? Did you guys get Chris and Lauren in on it, too? I'm not so sure about that. You guys, I said you were allowed to collaborate with the group behind you. Okay. Okay. Jordan, what did you do?
Well, I just saw that it would be, just going to a root of x minus 2 squared and then x plus 2 squared. Because then you have, that's just breaking everything down. Because if you first had,
I like the idea, but in jumping ahead, you made a little mistake. I like the idea, but in jumping ahead, you made a little mistake. It's little, but it did mess you up. It did mess you up. Wesley, how did you factor it?
I just did different purpose squares.
Cool. And what'd you get?
Squared plus 4, x squared plus 4.
oh, so it's like the same thing.
Half the same and half different. Half the same. Half the, yeah, right? Like you knew that it was 2 and 2 and 2 and 2. Be careful, because that's the proper factoring, right? Like that's a difference of squares. This is a perfect square of x squared, x squared. This is a perfect square of 4 and 4. What would happen if we FOILed? What would be your outer, guys, if you FOILed? Negative 4x squared, right? What would be your inner? What's negative 4x squared plus 4x squared? Poof, gone. Yeah, which is why we only have the x to the 4th and the minus 16. Difference of squares at its core. But I said factor, well, I didn't say factor all the way, but I said find all the zeros. Could you have stopped right here and set each factor equal to 0? Yeah. Yeah. But even though you could have done that, I'm afraid that some of you guys would have made a mistake in doing that, so I'm going to actually go one more step. Yeah, that's a difference of squares also, right? So how can I take this guy and break him down? Now, Jordan, use your trick. Just him, what could its factors be? And x.
Me and Tyler did that, but we did another set. So we had x minus 2, x minus 2, and x plus 4.
Here's the struggle. Here's the struggle. If you set this guy equal to 0, you would end up with x squared minus 4 equals 0. So x squared equals 4. So x equals plus or minus 2, which you can see right here. Right? What if you set that guy equal to 0? It's imaginary. You guys did some illegal factoring, which is so common for so many people to do. Square root of negative 4 isn't plus or minus 2. Square root of negative 4 is plus or minus 2i. So if you were to factor that guy, which is technically legal as long as they let you go imaginary, let you go complex, which they're going to make you do in section 2.5, you could factor, but we would have to go imaginary to get the x plus 2i and the x minus 2i.
The difference of squares, I can see how you got it just because that problem was pretty simple.
Yeah.
How do you do it? Like, how do you get to it? Because I can only know because I can see it.
This one, I gave it to you today as an opener before we get into section 2.5 because you can see it.
Okay.
So we haven't done the harder ones yet.
So we're going to learn that.
Yes. But I only gave you this one, and I only thought you guys could tackle it because it's a difference of squares, a special one. Okay, so hang in there. Do you guys see, though, why the zeros of this are not real? And yet, algebra 1, that people like to factor this. X plus 2, x plus 2. No, that'd be x squared plus 4x plus 4. X minus 2, x minus 2. No. X plus 2, x minus 2. No, that's a minus. These zeros are imaginary. So we had to do section 2.4 that we're going to grade right now, or else we couldn't have even gotten to the imaginary numbers. Does that make sense? So why do we time out and review? Because in section 2.5, we're going to look at zeros that aren't necessarily real. And maybe just a couple of you are like, why are there imaginary numbers anyway? Now, I'm not an Algebra 2 teacher, at least not right now. This isn't an Algebra 2 class. I'm not going to introduce to you imaginary numbers and all their applications, etc. But I am going to say something to the effect of, I is imaginary, true? Okay. So you could think of it as an off. Off, like it wouldn't show up in the graph. What's I squared? Real. On. I cubed. Negative I. Imaginary. Off. I to the fourth. Real. On. Is there any application in this day and age for off and on, switching back and forth and back and forth? Maybe light switch, electricity, off and on, circuits being broken or together. A cycle.
Like a cycle of a program.
Oh, that's what I was looking for. Computer programming, binary. Binary, ones and zeros. Ones are on and zeros are off. Now, not that a lot of you guys have delved into programming, but offs and ons. Imaginary, real, Anyway, you can dig a little deeper into it if you're curious. But just to give you a little peek at offs and ons are important in circuits, electricity, and in coding. Maybe imaginaries do apply in the real world. Anyway, all that to say, section 2.4, there was a purpose, there was a reason. Let's go ahead and go check it. Ready? Here we go. Evens. Sorry, 14, huh? Please, 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 please. TAs and me both, when we grade the homework spirals on test day, it's so confusing if you don't have numbers. Please, please, please. Please do the homework number. You don't have to write HW, just the homework number. It could be like in the corner. Section, page, numbers. It's for a few different reasons. Number one, some people accidentally miss a homework assignment, and so if you write this number but have the wrong page, we know what happened, what went wrong. If you have this page correct, but that number missing, and you have one fewer homework assignments, it's so confusing. If you write out what numbers you thought the homework were, then if I try to wait a minute, they're missing all these numbers. Oh, they wrote what? They wrote down the wrong ones. Now I might still take off points if it's not lining up with the ones that I want, or if all of your evens magically accidentally became odds. Yeah. Anyway, but at least I can see what numbers you were trying to do. So if you wrote down all the right ones, and then in here somewhere you didn't write 33, you didn't do 33, maybe I'll give some grace. Anyway, there's lots of reasons, and it makes it so you guys don't have to keep on looking at the assignment. You just have it written down. But thanks, Jordan, for asking. Number 8 was so easy it was hard. Oh, sorry, number 6. Complex conjugates. It's the snazzy name for the conjugate when you have an A plus BI, the A minus BI. Super helpful for division. Bless you. Number 8 was so easy it was hard. They're just asking. You guys got it done okay? They were just asking for who's the real guy? 13. Who's the imaginary guy? 4. Just asking for the coefficients. That's all. Number 26. Combined like terms. Did you kill a seal? Fix it. And don't do it next time. It's okay. So easy to do. Watch out for the seals. Distribute the negative. Number 40. Did you kill a puppy or did you foil it? Had to foil it. A lot of you did that in class yesterday. You did it well. But the I squared becomes a negative 1. Negative 1 times 16 is a negative 16 plus 25 is 9. Jordan.
26.
Yeah.
I put negative 11 I minus 3. Is that fine?
Your math was right. The form of your answer was wrong. Because a complex number is A plus BI. So it's kind of like writing a quadratic backwards. The order's wrong. Because you're thinking very complex numbers switch because you want the real part. Yeah. Yeah, just not with I's. Number 52. Did anybody do it differently? You didn't have to do it the way they did. Did anybody just multiply by I over I? Did it work? Yeah. So you didn't have to multiply the whole thing. I mean, you can. But as long as there's no plus or minus with the I, as long as it's not the whole complex number, it's 0 plus, you can just do I over I. It still works. And you end up with 7I. You could have done what they did, but some of you would be like, oh no, I did it wrong. I over I is perfect. It's fine. And guess what? I didn't give you too many this week, yeah? I wanted you to be able to check, and I wanted it to, yeah, it's kind of like a nice little lesson on complex numbers. But that doesn't mean that I have any questions. Is there anything odds or evens? Jordan. Yeah. Number 40, was he the squaring one? Number 40, just a quick reminder, because they make a jump. Like, they totally make a jump, and not all of you guys can make that jump, so let me remind you of where that came from. Yesterday, when I walked around the room, and I commended a lot of you were doing what to keep yourself safe and not killing puppies? But you can't foil right now unless you're really good at mental math. So what did you write out? It's the first thing I would do.
I foiled it, but I messed
Good.
up somewhere.
So 25. Our negative 20i. Our negative 20i. And our plus 16i squared. Remember when you have a negative number, I'm just going back because I make mistakes on negatives and positives. So when I have a negative 20, with subtracting another 20, when you're in a number line, subtraction always goes to the left. Here's your 0. If I'm subtracting negative 20, it's going to go more negative. So it's actually a negative number plus another negative. You're going more negative, hence the negative 40i. I squared simplifies to negative 1. Then we put our real parts together. 25 minus 16 is 9, and we're done. Do you find it, kiddo?
So that makes sense. I just did something.
Magically
I got
weird.
all of those right. Like I did
Yeah.
everything right. I just messed up somewhere, but
Okay. Did you make those ones 0? That's the common mistake.
I think that's what I did, which is weird because I never do that because I know.
It just happens when you go fast, right? And our brains were tuned into the imaginary numbers and puppies and foiling, and sometimes you just don't take enough of a second for doing like mental math
I
stuff.
think it was just
Yeah.
simple.
Yeah. It happens. I mean, on tests, some people get the right answer and write the wrong one in the blank. Like, there's so many silly things, right? I mean, our brains do funny things sometimes. And then the other one was 52. I wouldn't have done it their way. So let me just show. Some of you guys, in case you're wondering, some of us are auditory learners, meaning we can listen to math being said and our brains see it and they understand it. For other people, and I'm not saying that, Jordan, you're this way necessarily, but for other people, they're more visual. And so even though I say, hey, you can do I over I, some people don't actually see that. And they're just like, great, you said something. I need to see it. So just to show you what I would have done, I would have gone ahead and multiplied by I over I. The reason that we can, there's no like conjugate thing that I need to worry about. And an I squared becomes, everybody?
Wait, I thought that you multiplied by 2i.
Oh, you did it that way, like the book did?
Well, that's because I just remember we did an example in class yesterday and you can multiply by the denominator, so I did that.
Oh, okay. See, in my head, in my note, in the notes, I think multiplied by I. And the people that read that would have just done the I over I. But then some of you just saw like, oh, hey, it's the same thing. I was the denominator, so you're like, always do the denominator. It works both ways. Let me just finish this. It'd be a 7i, negative 14 over negative 2. The other way, which still looks different than the book, because the book multiplied by a negative 2i for whatever reason. I've just done a positive 2i. I put an or. That would have been negative 28i over 4i squared. And then that I squared turns into a negative 1. So remember, 2 times 2, I times I. Negative 28.
That's what I thought.
Simplify. Negative 28 over negative 4 is 7.
I got negative 7i because I didn't square it in the second step. I just left it as I.
Oh,
and
there you
that's
go.
why it was negative.
There you go. That would have messed you up.
How are they both ending up the same thing if they're two different ones?
Because I squared is a negative. And so a negative over a negative is a positive.
You always just multiply everything by I? Or is that just...
Only when, you guys had a homework one that was nastier, that was odd, right? Look at your problems. Which odd one had a plus or minus? When you have like this, I have to multiply by the conjugate. I can't just do I over I. I would do 1 minus I, 1 minus I, 1 plus I, 1 plus I, and simplify. So whenever there are pluses or minuses, I can't just do an I. Whenever there are plus, nope, yes. I over I, yes. I over I, no. 5 plus I over 5 plus I. Does that make sense? Okay. Yeah. I'm right here. Oh, yeah, he's the nasty one. I was waiting for that one. Thanks, Priscilla. That's almost always the one that gets asked. I hadn't heard it yet. It was nastier. Well, guys, look. These are worse than those. Because instead of just having one complex division, I have two. And I'm probably supposed to put them together. So put the two together, and it makes it definitely a harder problem. This one, in a way, is kind of nice. These first two, it gets worse, actually, in 63, 64, because they're not conjugates of each other. But still, I have two problems. Number one, I'm supposed to simplify this to be a complex number. And number two, I'm probably supposed to put those together. It depends on your brain as to which way that you would think first. I would probably think, based on the homework and what you were doing, I need to multiply by the conjugate, which also ends up happening to be the other denominator. So you kind of do two birds, one stone. You guys have heard that phrase before, right? You're doing two things at once in that you're actually getting a common denominator and you're multiplying by the conjugate. That's why these first two were kind of nicer and easier than the last two. But right now, I'm just trying to simplify my complex number by multiplying by the conjugate. On top, or I should say the first fraction, I'm going to have 2 minus 2i. And did you guys figure out what always happens with conjugates? If you FOIL, you're going to have 1 minus I, sorry, technically plus I minus I, the outer inner cancel, minus I squared. And then I'm going to get minus 3. Now be careful. I'm going to go ahead and just do 3 plus 3i. Just be careful. I haven't distributed the minus yet. That's where some people might have gotten messed up. And I still have 1 minus I squared. I squared turns into what, everybody? And 1 minus a negative 1? Now I'm going to distribute this negative. So I'm going to make it addition of the opposite. So I end up with a negative 3 and a negative 3i also over 1 minus a negative 1, 2. You have a couple options. One is you can go dividing everything in each fraction by 2 right now, or you can combine your fractions since they have common denominators. That looks kind of easier to me. What do you guys think?
Second.
Just combine? Because 2 minus 3 is a negative 1. Negative 2 minus 3i, sorry, negative 2i. It's negative 5i. Now, I guess in some ways you could stop. Like, you're not totally wrong. But like we saw yesterday, they want it to look like a plus bi. They don't want like everything divided by. So I'm just going to go ahead and say, remember, division distributes. Just like multiplication would. Dun, 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 dun. It's not pretty. I guess you could have done decimals. Negative 0.5 minus 2.5i. But it's right. Does that make sense, Priscilla? Cool. Kiddos, gotta get some notes. Section 2.5, okay? If you have any additional questions on 2.4, you know where to find me. I'll be here longer today. Yesterday I left a little bit early, but I think homework wasn't too bad. There were just a few places that our brain either was a little tired, or that just got a little bit trickier. But I think you guys have most of the ideas from section 2.4 down. Real quick, did anybody just notice what I just passed over and didn't really say anything about? Look up on the screen. Okay. It's okay. If you guys look at your calendar, which maybe some of you haven't been looking at, if you guys have been looking at your calendar, there is a quiz tomorrow. It's just a quiz. It's just like one little page. No multiple choice. Just show me your work on 2.1 to 2.4. And the nice thing is we've actually reviewed a lot of what we've done just today in class. Complex numbers, fresh on your mind. The section before that was synthetic and long division. Just know how to do it. Not the tricky problems, just the straightforward skills. Do you know how to do a synthetic? Do you know how to do long division? Not 2.5, not 2.5. We're going to take it 2, maybe 3 days on 2.5. But the idea of 2.5 is you kind of have to be at least okay on everything that we've done up until this point. So to help you in that and to help you for the rest of the chapter, we're doing a little quiz, not a big one. It'll be like 10 points. Tests are 100 points. On 2.1 to 2.4, which has to do with quadratics, finding h, finding k, either with the cheater formula or complete the square. Complete the square is probably safer. 2.2 had to do with end behavior of polynomials, even, positive or negative, odd, positive or negative. You're not going to have to graph a big old polynomial on the quiz. That part of 2.2 is not on there. It's the little individual skills along the way. Okay? So we're going to probably practice actually a few of them kind of today, but today in section 2.5 it gets harder. So I'm trying to give you a chance just to kind of time out. Remember the basic skills of 2.1 to 2.4. Look through your notes, maybe some homework, maybe the openers. We've done quite a few. I said for studying for tomorrow, look at the basics, not like the big old put it all together problems, but the basic skills, 2.1 to 2.4. Maybe look at homework problems, maybe look at openers. Because I said we did quite a few. Huh? Oh. It was a good thing to get clarification on, but no. No open notes. There are a couple times this year you guys get some formulas, but not right now. We don't really have, we have vertex form. Standard form. But yeah, not really. We're just trying to develop and master skills. You guys feel that though, right? Like things you've seen before, but let's go a little deeper and let's try to master them this time. Not just see them, but master them. Okay, section 2.5. So quiz tomorrow, 2.1, 2.4. Does anybody have Joe's number? Some of you guys. No? Hodgson? Yeah, you have football. Just text him and mention the quiz and be like, Miss D wanted you to have a heads up. Yeah, that'd be perfect. If he can be ready, cool. If not, he can talk to me or email me. Section 2.5, though, we got to get going. The nice thing is the example that you guys saw today could have been a homework problem from 2.5, but as Jordan said, it did have the trick of difference of squares. Fundamental theorem of algebra, I think it's actually one of your vocab hint from the homework in section 2.5. But it might say it a little bit differently. Fundamental theorem of algebra basically says every polynomial has at least one zero. And to be specific, polynomials of degree n have n complex zeros. Not at most n. That was section 2.2. We said at most n, but we had a different word after it. We had at most n real zeros. The opener that we did today in class. How many real zeros were there? Do you guys remember? 2. Just 2. Plus or minus 2. They were the only real zeros. So at most 4 real zeros, but there were only 2. But guys, how many zeros total were there? Oh. So the fundamental theorem of algebra says every nth degree polynomial will have n complex zeros. Just not all of them are real. So how many zeros? Let's just test this theory. How many zeros does this guy have? Guys, what is
2.
x equals 2? Many? 1. What's the degree? 1. It matches. The degree of x is 1, and there's 1 0. And you can think a line will only possibly go through once. A line is never broken unless it's a piecewise, and that's not a linear function. It's not polynomial if it's piecewise. Letter B, how could we find the zeros? How would we find the zeros? Yeah, factor. And some of you can do this mental math pretty quick, and some of you would need to actually think through the x. But it's x minus 3 times x minus 3. Wait a minute. It's only 1 0, and the degree is 2. Ha! We disproved this huge fundamental theorem of algebra. What's the multiplicity? We have 2 zeros and 1. We have 2 zeros, they just happen to match. So we technically do have 2 zeros. Not 2 different locations, but we're not even talking about locations because imaginary aren't locations on graphs anyway. Multiplicity means that when you write a factor, it's raised to a power. So this one would technically have a multiplicity of 1 because it's just 1x minus 2. This has a multiplicity of 2 because the fact that the 3 came from is being squared.
So for that, is that basically saying that there's 2 3's?
Yeah.
But without saying like x?
2 factors with 3 as the 0.
Okay.
Yeah.
So you have to write that down?
Well, I don't necessarily make you write it down every single time. Sorry, I wanted to move that. Right. If I ask you for multiplicity, like on a quiz or a test or in homework, they asked you to identify the multiplicity, then put it. Otherwise, it's more of an understanding of, wait, he's supposed to have 2. Oh, he does. Even though it's 1 location. And then letter H, have you guys already gone? Go factor him for me. He's a 3rd degree polynomial. He should have 3 zeros. I didn't say they were all real. Right? I would pull out the GCF if I were you. Hopefully you remember that second guy doesn't factor so well. And maybe you would get 3 zeros. Hopefully the opener helped a little bit. Did you guys find all 3? X equals 0. X equals plus or minus square root of negative 4. Oh, plus or minus 2y. 3 zeros? Yeah. But what's new in section 2.5? We're allowed to keep going into the imaginaries. Okay? So degree 1, 1 0. Degree 2, okay, yeah, there are 2 and 1. And then degree 3, there are 3. That's at the core of section 2.5. But just like practical application of 2.5, it's not just, hey, now there can be complex zeros. Now it's also, we can put together synthetic division, long division, complex zeros, real zeros to factor nasty polynomials. So to factor nasty polynomials, here I think is where you should always start. I mean, maybe look at the degree and be like, oh, I should be looking for this many. That's good, but you have to actually have a place to start as to where to look. And so this page is going to be a really, really, really helpful one as to where to actually start looking. That's not what I wanted. I'm graffitiing on my notes. Okay, hold on. There we go. A lot of you guys are going to look at the polynomial and just get stuck right away and be like, I don't like it. Say it. It's okay. Verbalize it. I don't like it. And then, but I'm still going to try. How do you try? You make a list of possible zeros. The book's going to say something like use the rational zero test or theorem. Long story short, go list out all the possible zeros. And then we'll talk about, after you look at the steps, form a list of possible zeros. How? Using this formula right here. And we'll talk about it. We'll practice it. You'll have it. You're going to form a list of possible zeros using this little fraction right here. Then we're going to work at narrowing down the list. And the 2 different ways of narrowing down the list that I would say, I'm coming right back to you, is going to be either plugging in and looking for a 0 or synthetic division. As we saw in section 3 with synthetic and long division, right? Plugging in gets you the same thing as a remainder. So sometimes plugging in is faster, especially you mental mathers. Or at least for really small numbers, like 1, -1, maybe 2 and -2. But if you get into 3 and 6 and 12 and you have things raised to the 4th and 3rd and 2nd powers, do synthetic. It's easier. But either way, we're looking for zeros. Okay, I heard a comment and I just went right over it. Did anybody still need to make it? Oh, yeah, Jordan. Yeah.
Just going back real quick, you had plus and minus 2i.
Yes.
So how did you get those?
You could look at it two different ways. I went too far. One way is that when you solve x squared equals negative 4, remember when you square root a squared, it's an absolute value. So I need that whole plus or minus. Huh? Oh, when I said equal to 0, I have to subtract the 4. And that's also where the I comes from. The other way of looking at it is this could have factored to an x plus 2i. That's the other way of looking at why there has to be 2. Is that cool? Okay. The constant term, guys, I really wish I had a letter. I really wish I did. Quadratics have a letter. It's always C. X squared plus bx plus c. But what about a cubic? Now what's the letter? D. Quartic, what's the letter? E, because now you have A and B and C. I can't give you a letter, but the constant term is just going to be the non-variable term. The one that should be written always at the end if it's written in the proper descending order. Leading coefficient will always be, well, leading. Yeah, the one in front of the highest degree term. So you could think of it as plus or minus the last coefficient over plus and minus the first coefficient. And technically, if you did it of each, it would be a plus or minus of the whole combination. But I want to go ahead and model this for you. So let me get an example up. I think I have one on the next page waiting. Haha, I do. Make them big. I want you guys to get down this polynomial. I want you to realize how scary the directions are. It's okay, you don't have to like it. Find the zeros. It's a 4th degree and there's no GCF. Life is over as we know it. Just kidding, we'll be fine, but it's okay not to like it. But we have to have a place to start. We could look at it and say, you know what? I know exactly how many zeros he has. How many zeros will he have? 4. But do they all have to be real? Well, that's a bummer. I don't even know how many I'm really looking for. Anyway, but I know at most I'm looking for 4. The directions say find the rational zeros. It's not even making me look for irrational, which are yucky like square root of 3, which wouldn't show up in nice factoring. It's not making me look for irrational, nasty decimals that would come out of your calculator that aren't nice numbers when you factor. It just wants me to find the nice zeros. Now, rational zeros, I look at this possible list of rational zeros, then I have to somehow test them and find any that are actual. So here's the test. Off to the side. Possible, rational. It's not all possible because as soon as you open up the irrationals and as soon as you open up the complex numbers, well, there's all sorts of other stuff that can come tumbling out. Rational zeros, there are only so many. And here's how you plus or minus, make a fraction. Look at the last term. What factors make 6? 2, but also 1, but also 3, but also 6, right? 1 goes into 6, 2 goes into 6, 3. Only rational. We don't have to go into like weird numbers that might multiply. Just whole numbers, 1 and 2 and 3 and 6. Now I need the leading, yeah. Joe's already reading it. The factors of the leading coefficient. Who's in the front?
1.
Okay, well, that's easy. 1. Now I pair them all up. Now this one's, I don't know. It's super basic because you only have one number in the denominator. So what's 1 over 1? 1. What's 2 over 1? 2. What's 3 over 1? This isn't always the case, though. Sometimes you have multiple numbers and you have to pair up all the different possible. Now here's the struggle, guys. Are these actual or possible? So looking at our steps, don't we have to somehow do a trial and error testing process? So work with me. I need either the remainder to equal 0 or the function when I plug in to equal 0. What sounds easier to you guys if I'm just testing plus or minus 1? Should I do synthetics for each one or should I just plug in? That's what I think. 1's easy to plug in, right? So what if I plug in 1? I get 1 minus 1 plus 1 minus 3 minus, no. 1 to any power, because he's a positive number, stays the same, right? 1 to the fourth, 1. 1 cubed, 1 with a minus. 1 squared, 1. 3 times 1, 1 with a minus. Long story short, is that 0? No. No. 1 minus 1 is 0. Then I have 1 minus 9. Nah, not 0. So what do I know about 1? Forget him. Okay. How about negative 1? He's not too bad to plug in, right? Let me give you a second. You go ahead, because I'm going to do it fast. Because I know that a negative raised to an even power stays positive, and a negative raised to an odd power flips negative. Six minus 6 is 0. Just found one. Did you guys find it too? Now technically we're looking for up to 4. Maybe we'll find all 4 in the rational zeros, maybe we won't. But we have to work our way through the list. Struggle is as soon as we get to 2, some of you will start tapping out. Why? Hopefully not of the problem, but at least of the plugging in. What happens as soon as you get to 2 for some of my non-mental mathers? 2 to the fourth, some of us know it's 16. 2 and 2 is 4, 2 and 2 is 4, 4 and 4 is 16. Or 2 times 2 times 2 times 2. Some of you guys are like, no. If you don't mind the mental math, sure, go carefully. Just do it carefully. I have 20 and I have 20. 20 minus 20 is 0. I just found me another one. But some of you are like, I don't like that mental math. Okay, remember, there is another way. You don't have to do mental math. Why are there R's up here? What else? Where else could I be looking? Okay, so you could plug the 2 in the box and you can say, I'd rather do this math because it's easier on my head. So you could do 1, negative 1, 1, negative 3, negative 6. For some of you, literally, this is easier, so do it. Bring down the 1. You just have to do 2 times 1 and then add. 2 times 3 and then add. And then add. Yay, he goes in. Whether you do the 0 from synthetic or find the 0 with synthetic, or if you had done synthetic with a positive 1, you would have had a non. Whether you're saying or it doesn't work, synthetic will show you that, but so will plugging in. It depends on whether you're a mental mather or not as to which one's better for you. How would we keep doing this problem? We would just keep going. Plug in negative 2, plug in positive 3, plug in negative 3, plug in positive 6, plug in negative 6. Wait, hold on. Didn't we just break this guy down from a 4th degree? Technically what we would say is a cubed? So couldn't I kind of ignore these possible rational zeros and do some more possible rational zeros and say, wait a minute, hold on. This guy, I can only look at the 1 and the 3. Oh, well, forget the 6s. It's not going to work. If it hasn't worked yet, it's not going to work now. And forget the 2s. If it hasn't worked, I already used one. Yet, it's not going to work now. I can actually break down a polynomial if you do synthetic. If you do plugging in, you can't really break down anything because you don't have anything left after division. Anyway, a couple tricks to use. Jordan, go ahead.
Once you have the numbers, it's pretty simple, but how did you get the numbers?
I looked at the last term and the first term of my polynomial when it's written in descending order. Last term,
1 and 6.
Just the coefficients. The signs don't really matter because I'm looking at pluses and minuses anyway. So what goes into 6? 1, 2, 3, and 6.
Oh.
What goes into 1?
Everything in between.
Everything in between that factors in.
Okay.
Priscilla.
So say like there's like a 2 or like a bigger number than 1 in front of the leading coefficient, then you put those in the denominator.
Like say it was a 2, I would need 1 and 2. So I'd have to do 1 over 1, 1 over 2. 2 over 1, 2 over 2. 3 over 1. So I have to make all the possible pairs. But I would still start with the easy ones, trying to see if I could break it down. And technically, if you find an easy one, like for instance, I was just about to show you guys, if you find easy ones that go in, couldn't you say, wait a minute, I just figured out that negative 1 also goes in. I'm going to break them down some more. Because then I can go ahead and bring down the 1, negative 1, 0, 0, 3, negative 3. Couldn't you figure out exactly what's going on if you just broke it down a few times? I have the factor x minus 2, that's the 0. x plus 1, and now x squared plus 3. Should I even keep looking for any more rational zeros if that's all that's left? No. That's going to be x equals plus or minus square root of 3i. Not rational. I found my only 2. I'm done. Dun, 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 dun. So is synthetic really helpful? Yeah. Why? Because if you can find a 0, synthetic breaks it down and makes it easier for the next repetition. Guys, the big idea of section 2.5 is, can you factor nasty polynomials? Tomorrow, beginning of class, I'm going to have an opener about this nasty polynomial, seeing how far you and your group can go to factoring him. But I'm going to start today by taking what Priscilla asked and doing factors of the last over factors of the first. What are my possible zeros if I took my last and my first? Plus or minus 1, plus or minus 1/2, plus or minus 3, and plus or minus. But am I going to start with fractions? Heck no, tech no. Get out of here. See you guys later.
But if you make a mistake, one step is like division. It's like in the first one.
Right? It messes up your
Yeah.
whole problem.
But I think people will like know what it is.